and fellow learners, welcome to Module 7 of Agroecology, Science and Practice. I am Dr. Tadeo Kahigwa Tivasima, lecturer at Mountains of the Moon University in the Faculty of Agriculture. And for this course, as earlier mentioned, it is particularly for the learners that are pursuing a master's in agroecology. In session 6, we talked about the different agroecological farming systems and practices, of which our last mention was of well-managed agroforestry systems. But all these thrive well on healthy soils. And today, we want to talk about soil health and management. First to note is that actually soil is a living thing. It constitutes air, water, living organisms, and mineral matter. And that both micro and macroorganisms determine a lot what happens in the soil in terms of its capacity to provide nutrients to plants. As human beings, we cannot feed on these nutrients, but we actually finally derive them from the food. So, these nutrients are very important for the well-being of the human person. The organisms in the soil have a very critical role to play in the sustainability and resilience of farming systems. They contribute to the cycling of nutrients. They sequester soil carbon. This is very important also in the mitigation of climate change. They improve the soil matter. They determine the decomposition. So with the dead soil, soil organic matter is below 3%, and that is the minimum that we should have in a soil that can, even if it is to use synthetic fertilizers, once the organic matter in the soil is below 3%, nothing happens. So this is very important, because without the living organisms in the soil, then the decomposition of materials that are deposited on or under the soil cannot be accomplished. These living organisms also contribute to the physical structure and water regime modifications. They, for example, determine the aeration in the soil, the soil pores, through their movements in the soil, for example, earthworms. They enhance the amount and efficiency of nutrient acquisition by plants. Some nutrients can be fixed. When we talk about fixation of nutrients, it means they are in the soil, but they are fixed to the soil particle and they cannot be absorbed by the plants. But when these living organisms come into play, they can facilitate the adsorption of these nutrients to the root structures of the plant that absorb the nutrients from the soil. They also contribute to enhanced plant health. We know that a crop or a plant that is actually weak is a target for most of pests and diseases. So when a plant is well nourished due to appropriate soil nutrients that are contributed to by the living organisms, then such a plant is actually strong and can tolerate different pests and diseases. We should note that soil contains thousands of different organisms which interact and contribute to the global cycles that support life. The contribution of soil microorganisms to nutrition is linked to their involvement in geochemical cycles. And these cycles are mainly the nitrogen cycle, the carbon cycle, iron, phosphorus, and through the reactions that they catalyze as a result of enzyme synthesis, these activities are enhanced or fastened. Soils also harbor numerous microorganisms which produce antibiotics, reducing the saprophytic growth of plant pathogenic agents or eliciting defense reactions in plants. So these microorganisms are playing also a role in the control of soil-borne diseases. Overall, the microbial biodiversity of soils contributes not only to the productivity but also to the stability of the agroecosystem and thus to its sustainability. We have mentioned in the different roles of the soil organisms how vital it is that these microorganisms and the macroorganisms are contributing to resilience, the ability for the farming system to bounce back when there is disruptions in the functioning, but it is able to recover because these soil organisms will reset the system and it will bounce back to normal. As an agroecologist, it is important to know about nutrient cycling and organic matter management because these are the key foundations for a healthy and functional soil. When we say the soil is fertile, this is a very key element of soil fertility and it contributes in many cases to also the price of land. For example, when someone is buying land, they will consider the fertility of the soil, and this is due to the ability to recycle nutrients and organic matter by the farmer. So once this is not optimized at the farm, even the value of the land is undermined. Nutrient management through nitrogen fertilizer application increases food production and supply. You might have come across the Haber process through which nitrogen was able to be optimized in terms of availability, and we realize that this nitrogen is a very big constituent of our food and also of our bodies. Much of the nitrogen fertilizer applied to crops is lost to the environment through nitrate leaching, volatilization, and denitrification. These processes result in too much loss of nitrogen, and we actually currently have a challenge of nitrogen being much in the air than in the soil where it is most needed. So the processes that can bring back this nitrogen from the atmosphere to the soil is very important. Fertilizer application is likely to increase eutrophication and global warming through nitrous oxide emissions. And this is one of the challenges why agroecology is advanced as opposed to conventional farming systems where fertilizers, for example NPK, are applied without appropriate technique, and therefore contribute to nitrous oxide being much released into the atmosphere and consequently resulting into global warming. The extent of the current losses highlights the need for further improvement in nutrient use efficiency within the scope of sustainable intensification. So even if we try to intensify without also intensifying the nutrient recycling in the soil, then however we have good seed, apply irrigation and pest management, still due to limited nutrients in the soil, these interventions may not contribute much to the productivity of the land. Sea soil particles and plant residues are comprised of large quantities of nutrients which are unavailable to plants. Improving the health of soil microorganisms can facilitate weathering of soil and improve the availability of these nutrients. The microorganisms facilitate decomposition of plant residues to form humus that is rich in nutrients. So recycling of nutrients within the farming system and maintaining organic matter are the best way to improve soil fertility with minimum harm to the environment. We should note that most of these nutrients exist in nature and do not necessarily have to be created. So once we have a mechanism of recycling them, it is not necessary to purchase from input shops. Soil fertility can be improved through maintaining a closed system. This is a system where we minimize any nutrients leaving the farm. And how do nutrients leave the farm? They leave through sale of products, erosion, and these other processes that I have mentioned, such as volatilization. So appropriate composting mechanisms are very necessary even when we are trying to optimize the nutrients on the farm, and ensuring that most of the primary processing can be done on the farm such that the materials are maintained. Also, integration of legumes can support in the improvement of soil fertility and improving the functionality of the microorganisms is also very important in ensuring that the nutrients are maximized and made available to the plants on the farm. For this session, we have tried to throw more light on soil health, but also on optimizing nutrient availability on the farm. Thank you for participating in this session, and I look forward to your participation in the 8th session for this course on agroecology, science and practice. Thank you.